Good morning. So today we're going to talk about solving equations, and yesterday we started chapter 4 by discussing simplifying expressions. So those were concepts you learned in grade 9, like collecting like terms. And today we're going to take it a step further and we're going to solve equations. So if you haven't done so already, please pause the video and do the minds on for 4.1. Okay, and so for today, by the end of today's lesson, you're going to be able to solve simple linear equations, and you're going to be able to check them, your answer using substitution. All right, so let's go. So the minds on today was to simplify a pretty complicated, I would say, expression, because there are a couple of sets of brackets in there. So the first objective is for you to get rid of those brackets by multiplying anything outside the brackets through into the bracket. So we're going to take that 2 and we're going to multiply it into only the first set of brackets. So we only do it until we see a closing bracket, and then we stop. And then we're going to do the same for the minus 3. So this is minus 3. You're going to distribute that minus 3 in, and then you're just going to gather up all your like terms. So 2 times x is just 2x. 2 times minus 5 minus 10. Minus 3 times 2x is minus 6x. And minus 3 times positive 9 is minus 27. And so when we gather up our like terms, we can physically move them. So we can move this minus 6x beside the 2x. Make sure you take the sign in front of it with you. So this is 2x minus 6x. And then we still have minus 10 and minus 27. So when we combine all that, remember we're not changing the x's. We've got the same variable, so we're allowed to combine the numbers in front. So 2 minus 6 is minus 4, and we just tack the x on. So we have minus 4x's, and minus 10 minus 27, of course, is minus 37. And so once we have it down so that we have one term with just an x and one term without an x, we can't combine that any further because they have to be the exact same terms. They have to have the same variable, and this one doesn't have the x. So we know we're done. Okay, so let's move on to the lesson. So a couple of definitions that we could discuss. Expressions are what you were working with yesterday, and so those are just terms that we have added or subtracted to create this simplified expression. So 2x plus 7 is an expression. An equation is an expression that is equal to another expression. So if we have 2x plus 7, that's an expression, and it's equal to 4, which is really just another very simple expression. So an equation differs from an expression by that equal sign. So to solve an equation means you need to find an answer for the variable or a value for the variable. And in order to do that, you need to get the variable all alone on one side of the equal sign. And two important rules that you're going to use when solving equations are the whole idea of opposite operations. In order to move something from one side of the equal sign to the other, you need to use opposite operations. The opposite operation to addition is subtraction, and the opposite operation to multiplication is division, and vice versa. The opposite operation of subtraction is addition. The opposite operation of division is multiplication. Okay, the second important rule that you're going to use is you're going to use BEDMAS, but it's going to be backwards BEDMAS. So you're going to get rid of all the additions and the subtractions first, and then you're going to eliminate multiplication and divisions. All right, so let's solve and check the following equations. So we have x plus 2 equals 5. If we want to get x by itself, we have to get rid of that plus 2 on the left-hand side of the equal sign. And so we're going to do that by subtracting 2. So we have x plus 2, and then we're going to subtract 2 on that side. And the idea is that if our equations are balanced, we need to have the subtract 2 on both sides. Okay, in that way we know we've still got the x plus 2 equals 5. We've subtracted 2 from both sides. So we have not really changed the equation, because if you subtract 2 from both sides, then you haven't changed it. All right, and so if we simplify that now, we know that x plus 2 minus 2 is just x, and this is equal to 3. Now, I don't normally show the opposite operations when I do it. I usually just end up moving the 2 to the other side, showing this as x equals 5 minus 2. But if you want to do it this way, you're perfectly welcome to do that. Okay, and I'm going to continue to do the opposite operations for a while, but then I'll probably just change back to just writing it as moving this negative 2 over. So get comfortable with either one. It doesn't matter to me what you do. Okay, let's check. Does x equal 3? Well, I'm going to sub x equals 3 into the original equation, or the original question. Okay, so let's write down what the original question was. It was x plus 2 equals 5. And now I'm just going to sub in 3 plus 2 equals 5. 3 plus 2 is 5. 5 equals 5. And so I have that left side equals right side, and I know that then that my answer is correct. I can just put is the solution. All right, there we go. Let's do the next one. Actually, you know what? I'm going to ask you to do the next one. Just pause the video and solve for m. Okay, so m minus 3, I know I have to add 3 then to both sides. So I'm adding 3. And I end up with m equals 7. I'm going to check. So I'm going to have m minus 3 equals 4. So that's my original. And then I'm going to sub in my value for m, which I got 7 for m. 7 minus 3 equals 4. Notice I'm not bringing anything to the left-hand side. All I'm saying is, okay, what's 7 minus 3? Well, that's 4. This one's already 4. And so I have that left side equals right side. Okay, so this is a different operation. Oh, I didn't conclude. So I can just say, therefore, m equals 7 is the solution. Okay, let's try the next one. This is a different operation that is happening to the a. In this case, a is not being added or subtracted from, it is being multiplied by a number. So in order to get a by itself, we have to do the opposite operation of multiplication, which we decided was division. So we are going to take our 4a equals 24, and we're going to divide on both sides by that 4. So 4a divided by 4, is just a. These cancel each other out, and you've got 24 over 4, which is just 6. Now we can check that one as well. We're going to write down our original, 4a equals 24, and then all we would do in this case is substitute in for our a. So we decided that a was 6. And so 4 times 6 is 24 on that side. We still have a 24 on this side. Left side equals right side. Therefore, a equals 6 is the solution. Okay, not so bad, huh? All right, so that's the first 3 examples. Let's move to the next page. You want to give the next one a try? I'm going to ask you to pause the video and try this next one, and then come back and check in, see if you got it. Okay, so for this next one, n over 5 equals 3. There's a number of ways that you can do this, but if we're talking about opposite operations, the operation that's happening to the n is division by 5. And so in order to do the opposite operation, we would have to do multiplication by 5 on both sides. So I'm just going to say 5 times n over 5, I'll put that in brackets, equals, and then I have to do the 5 times on this side, 5 times 3. And then when I simplify this, oops, sorry about that, not sure what happened there, 5 times, there's a couple of ways I can do this. I can say 5 times n over 5, so just multiplying 5 times n, and then there's like an invisible 1 down here, and 1 times 5 is 5. Okay, so tops by tops, bottoms by bottoms. And then 5 times 3, of course, is just 15. Well, 5n divided by 5, the 5's can cancel out, and we should just have n on this side. That's why we multiplied through by 5 in the first place, right? To get n by itself. And we'll check. So I would start with the original, n over 5 equals 3. I'm going to substitute in then my value for n, which was 15. So I'll just put that in red there. 15 over 5 equals 3. Is that true? Yes. 15 divided by 5 is 3. And we have 3 on this side still. Left side equals right side. Therefore, n equals 15 is the solution. That was one way to do it. I personally sometimes prefer cross multiplying, and you're well aware of cross multiplying from our first chapter. So what we would do in this case, I'll just do this in green, and then I'm going to erase it so that I have some more room. But I would just n over 5 equals 3. That's like saying 3 over 1. N times 1 is n, and 3 times 5 is 15. So that's cross multiplying. But you can do either one. It doesn't matter which method you use, as long as you're not breaking any other rules. Okay, so I'm just going to erase that so that I have room to do the next one. Okay, so next one says 2x plus 1 equals 7. So I need to solve for x. This one's a little trickier because now we're getting into more than one step. So the first thing I need to do is I need to get rid of the addition that was put onto the 2x. You can see that x had a couple of things happen to it. X started out as x, and then it got multiplied by 2, and then we added 1 to it. And if we have to undo all that, we have to do it in the opposite order to which the things happened to the x. So, as I said, the first thing that happened to the x was it got multiplied by 2, and then the 2x was added to by 1. So now we have to go opposite operations in the opposite order. So now we're going to start with the last thing that happened to it, which is adding 1. We're going to subtract 1. And then the opposite operation of multiplying by 2 is dividing by 2. So here we go. I know that's a mouthful. Let's see. So we decided we have to get rid of this plus 1. The opposite operation to that, of course, is just subtract. Oopsie. I'm just going to subtracting 1, not. I was just going to write 7 here. So let me just erase that. All right. So 2x plus 1 minus 1 equals 7 minus, again, the 1. All right, so let's simplify that then. That's going to be 2x equals 6. And then the opposite operation of multiplying that x by 2 is dividing that x by 2. So we're going to divide both sides through by 2, as you usually do when you're trying to detach to get x by itself. And you're going to end up with x equals 3. Let's check that one. So we start out with 2x plus 1 equals 7, our original, and we're going to sub in x equals 3. So 2 times 3 plus 1 equals 7. Is that true? 2 times 3 is 6, plus 1 equals 7. 6 plus 1 is 7. Left side equals right side. That's true. Then we know that x equals 3 is the solution. Okay. Let's keep going. I'm going to get you to try the next one, so just pause the video and see how you do. Okay, we've got 3x minus 17, so we're going to add 17 to both sides. So this is going to be 3x, and 28 plus 17 is 45. When I have to divide both sides by 3, and I end up with x equals 15. We're going to check that one. 3x minus 17 equals 28. Substitute in 15 for x. Let's see, 3 times 15 is 45. 45 minus 17 is 28. Left side equals right side. Therefore, x equals 15 is the solution. So hopefully you got that right. If you're having difficulty with these more complicated ones, please pause the video and come and ask me some questions. All right, let's move on. 4 minus 3x equals 16. Well, this one looks a little bit different. What I would say is what we've done with this one, we started with the x, we multiplied it by minus 3, and then we added 4 to it. Okay? So now what we're going to do is the opposite of that, which is subtract 4 from it. So we're going to have 4 minus 4 minus 3x, and then of course remember we have to do the same thing to this side. If we subtracted 4 on the left, we're subtracting 4 on the right. So that's the first thing. So let's simplify that down to minus 3x equals 12, and then we're just going to divide through by the minus 3, and this is a very common mistake that people forget to divide through by the minus. So we need to get rid of minus 3 to get x by itself. So we've divided through by minus 3. This now is going to become x, and this is on this side minus 4. Let's check that. We get 4 minus 3x equals 16, and let's see, 4 minus 3 times minus 4 equals 16. So 4 minus 3 times minus 4 is plus 12. So 4 plus 12, does that equal 16? Sure does. So 16 equals 16. Left side equals right side. Therefore, x equals minus 4 is the solution. Okay, so that one was a little bit tricky. Okay, for the next one, 3k divided by 4 equals 9. So you can think of this as k has been multiplied by 3 and divided by 4. And so the opposite of that would be to multiply by 4 and divide by 3. We can do that all in one step, believe it or not. We can multiply by 4 and divide by 3 in one step by just writing 4 over 3 times 3k over 4 is equal to 4 over 3 times 9. Okay, so we're multiplying by 4 and dividing by 3, which is the opposite of what happened to this one. This one was multiplied by 3 and divided by 4. And when we do that, we end up with 12 over 12k. So 12 over 12k can be simplified. And this one is really 4/3 times 9. You have to write this as a fraction, so 9 is 9 over 1, and then you can just multiply the tops by the tops and the bottoms by the bottoms. So 4 times 9 is 36, and 3 times 1 is just 3. And when we go to simplify this, 12 over 12 is just 1, so we can just write this as k. It's like 1k, remember? And 36 divided by 3 is just 12. So that's one way of doing this one. We can check now to see if we have the correct answer, because this one's tricky. So we start again with 3k over 4 equals 9. And then if k is 12, so it's 3 times 12 all over 4 equals 9. Well, 3 times 12 is 36, and 36 divided by 4 is 9. So 9 does equal 9, and left side equals right side. Therefore, this case 12, k equals 12 is the solution. That's a k. Okay, tricky for sure. And I'm just going to give you an alternate method for doing something like this, which I think is much easier. You can also think of this as 3k over 4 equals 9. You can think of this as k has been multiplied by 3/4. And if it's being multiplied by 3/4, then it's to get k by itself, you need to do the opposite operation, which is divide by 3/4. So if you have 3/4 k and you divide by 3/4, you must do that on both sides, right? So this is going to be 9 divided by 3/4. And when you divide by the same coefficient, then these cancel out as per usual, and you get just k. And then 9 divided by 3/4, if you do that on your calculator, that does equal 12. Okay, so you don't have to think about multiplying through by the reciprocal. You can think just about dividing through by that coefficient of the k, which is in fact this whole thing. So pick your method. I don't care which one you use. And if you don't understand one and you do understand the other, then just stick with it. It's fine. So can you try doing I by yourself, please? Just pause the video. All right, so let's go ahead and solve for m here. So m is being divided by -2. So I'm just going to multiply then m by -2. So -2 times m over -2. And of course I have to do the same thing to the other side. So -2 is going to also have to be multiplied by that 4. So then we have -2 divided by -2, which cancels, and we're just left with m as we expect. M equals -8. So now we're going to check, and we're going to see that m over -2 equals 4. And oops, got to erase that. And when we go to solve, then we're going to substitute in -8 over -2 equals 4, and -8 over -2 is just positive 4, because a negative divided by a negative is a positive, and left side equals right side. Therefore, x equals -8 is the solution. Okay, so I know some of that's tricky, especially when it gets into the fraction stuff, but practice makes perfect for this kind of thing. So please do your consolidate now and put it on my desk when you're finished, and then get to work on the textbook work that's been assigned, please. So you're going to do the consolidate for 4.1, and you're going to do the homework. Or the textbook work, actually, for 4.1. Thanks.